Thanks so much. Okay. So what did you guys come up with for your coefficients? 2, 3, 1, 6. Did everybody come up with that? No, yeah? Did you get that now?
I was lost after I got 2.
Okay, so you got the 2 in front of aluminum chloride. Okay, so you start off, you have 1, 2, 3, 1, 2, 1, 1, 3. So you got the 2 in front of the aluminum chloride. Now, after you put a coefficient in front of this, you have to think about what else does that coefficient impact. So maybe that's where you're getting stuck. So 2 times 3, instead of having 3 chlorides now, you have 6. So now you have 6. That's where this 6 comes in. So then, okay, to get that to balance, I have to multiply this one by 6. And then your hydrogens are impacted because now you have 6 here. Well, 6 is not equal to 2. What do I have to multiply in order to what do I have to multiply 2 by to get 6? Right. And then when you multiply the 3 here, you get 3 sulfates.
So for the sulfates, I put 4 for the left side and 4 for the right. I didn't do
Oh, okay.
1. I was looking at that.
And so remember that polyatomic ions, if you have more than one polyatomic ion, that's when you'll have the parentheses. If you do not have a parentheses, you only have 1. So good to know this now.
Thank you.
Oh no, glad to. Okay, so this one, yeah, that's a good suggestion too. Yeah, drawing your parentheses. That's what you were saying, right? Yeah, it's very helpful. Okay, this one we have 1, 1. Sulfur, 1, 1. Oxygen. Careful when you're tallying up your oxygens on the right, because how many oxygens do you have? 3. All right, so everything looks good but the oxygens. And so this is a case where what I told you, stay away from the balancing the one that's in both products. So what am I supposed to do? You have an odd number of oxygens on the right side and an even number on the left side. Whenever you have that occurring, make the odd side even. Does that make sense? Make the odd side even. So you will have to put a 2 in front of one of these products. So trial and error. If you put a 2 in front of SO2, that makes 4 here, plus 1, that makes it 5. That's still odd. That doesn't help. So whenever you have this, make both sides even. If I put a 2 in front of PBO, now I have 2 plus 2 gives you 4. That makes it a lot easier to deal with. But now how many lead atoms do I have? 2. So now I'm going to have to put a 2 in front of this one to get that to equal each other. But then when I put a 2 in front of the sulfur, I get a 2 sulfur. So it's like this bad dream where you can't, you have this, cannot balance this. If you come over here, you're going to have to put a 2 here. You put a 2 here, but then that 2 also impacts how many oxygens you have. Okay, so now let's tally up our oxygens. I have 2 times 2 gives me 4 plus 2 gives me 6. What do I need to multiply 2 by? So if that one was a little tricky for you, that's okay, because you have the oxygens and you didn't know this little trick. Make both sides even. Now these coefficients, can they be simplified? 2, 3, 2, 2. Cannot be simplified. So looks good. Questions on this one? All right, let's go. I have practice problems here. And I didn't give you that much space. Sorry about that. If you need, a lot of students write on a piece of paper. Work through some of these and then we'll go over the answers. Done balancing these chemical equations. I will give you the answers. And so 1, 2, 3. So 1, 3, 2. Number 2, 2, 2, 3. Number 3, 2, 1, 2, 1. Number 4, 2, 1, 2. Number 5, 2, 1, 2, 1. Number 6, 2, 3, 6, 1. Number 7, 1, 2, 1, 2. Number 8, 1, 3, 1, 3. Number 9, 2, 1, 2, 1. Any questions that came up during that? Okay. On the next page, there's a reaction. Copper metal reacts with aqueous silver nitrate to form silver metal and copper 2 nitrate. This is an oxidation reduction reaction. I want you to write the balanced chemical equation for this right now. So go ahead and convert that into chemistry speak. What'd you come up with? Cu. Uh-huh. Is that the correct formula? CuNO3, 2, because nitrate is -1. Cu plus 2. Yeah. So it's easy to make mistakes. And this brings me to a very important point. The pre-lab for experiment 9. You are doing this. You're writing out a chemical equation from words. If you find that you spend hours upon hours trying to get a chemical equation to balance, most likely you have the incorrect formula. So don't despair if it's just not working out. More than likely, it's because you wrote something incorrectly. Is this equation balanced, by the way? No, it's not balanced. So how would I balance it? 2 in front of the AgNO3, 2 in front of the silver. This reaction is an example of an oxidation reduction reaction. Now, some professors will make you sing with them about oxidation and reduction. But the thing about oxidation and reduction is that they always go together. You know that song about love and marriage go together? That's how oxidation and reduction are. I'm not going to make you sing that. But, always think if something's getting oxidized, then something else must be getting reduced. And we're going to go through and be able to identify what's getting oxidized and what's getting reduced. Now, in this chemical equation, it helps when you're trying to figure out what's getting oxidized, what's getting reduced, if you just write what's changing in one reagent from left to right. So copper went from copper metal. What's the charge on copper on this side? +2. And then silver went from, what's the charge on silver on the left? +1 to silver with a charge of 0. So when it's just a metal, if there's no charge, that is a charge of 0. So we're going to be able to go through and identify what's getting oxidized and what's getting reduced. Oxidation is the loss of electrons. Reduction is the gain of electrons. So when you're looking at these two, these are called half reactions when you split it in half. When you're looking at these two half reactions and you're saying, well, what's happening to this charge on copper? It went from copper being completely neutral to copper +2. It must have lost electrons. On the other hand, silver went from +1 to 0. It must have gained an electron. So this is a case of where, this is what I've rewritten this here. This is a case where copper has lost electrons. So you would say that copper is getting oxidized. Copper's getting oxidized. And if copper is getting oxidized, then what must be happening to silver ion, or silver nitrate? It's getting reduced. So students have a hard time working these problems. And I always, say oil rig or Leo the Lion says grr. So what? So these are just little acronyms to help you remember what oxidation and reduction are. So oxidation is losing electrons. Oh, when I was taking chemistry classes, I learned oil rig. And then reduction is gaining electrons. There's another chemistry faculty member here, and she's like, you can't say oil rig. You've got to say Leo the Lion says grr. So whatever makes it stick for you, I'm not at all offended if you like the Leo the Lion says grr. But Leo is losing electrons, oxidation, gaining electrons is reduction. So when you write the equation above without the anions, it's a lot easier to see what's going on with these metals. They're going from a neutral charge to a positive charge, or from a positive charge to a neutral charge. So we'll practice some more.